Problem number 2, giving 3 positive real numbers A, B, C. A, C are different than 1 and alpha is different than 0. Find the wrong answer in the following choices A, B, C, D. All these issues or problems have to do with logarithm. So let's go and revisit logarithm. Logarithm is defined as one of two ways. The actual definition is defined as log of x is defined as the areas under the curve 1 over x between point 1 to point x. The reason why log of x is defined as such is because using the conventional way to find the integration of some function of the form x raised to the power of n, where n is equal minus 1, or in this case x minus 1, which is also written as 1 over x, we cannot apply the general integration formula for the variable type x raised to the power of n when n equal minus 1. Therefore, they have to devise a scheme to capture the integration of 1 over x, and that is defined as logarithm of x. Note that often it's written without any of the indexes right after the word log, and that means it is log natural, or you can write log e of x. Often people will just don't write e here. Now, note that as far as values of log goes, when x is 1, obviously this area here does not exist because x coincides with 1. So therefore, the area is equal 0. And when x becomes a value of e, then the area becomes 1. E is actually defined in a way which is coincidentally equal to the sum of a series of ratios of x raised to the power of k over k factorial when k is from 0 to infinity. By k factorial, it means like this. This number is equal to k times k minus 1 times k minus 2 and so on until times 2 times 1. Okay. In another video, which I already posted, I can explain more the relationship between the function e of x and log of x, and how there's a lot of coincidences between these two. But let's go back to the definition of logarithm. Logarithm is also defined as if you find a number a such that when you raise the e to the power of a and it is equal to b, then a is defined as a log of b. And this is what we call Neperian. It actually is a proper name. And or we call natural log. And the base here is e. E is a transcendental number which has a value of some 2.7 something, and this thing does not end, much like the value of pi equal to 3.14159 so, right? Now, the thing to note is if b is written as e raised to the power of a, then a is said to be log of b, or we can write it as A equal to log of B. In the engineering problems and so on, we use log base of 10. In other math problem, we also use log base of an arbitrary positive number called n, which we will talk later down here. Let's stick to the base of e for now. The rule of thumb is, since b is written as e of a and a is written as log of b, we put this, substitute it back into here, so we got this. Likewise, when we say we take log of b and b is e log of b, so we also have this. You will find the similarities here. This number is the same as this number. That means if you put a number like x, you can equate it to log of e of x. Again, let me highlight this in a different color so you can see it. This number is equal to this number, and in here you got a formula. So you can substitute any arbitrary number x here, and you can write x equal log e of x. This log and e are two functions that we call they are inverse functions of each other. Likewise, you noted that b is equal to e log b. We already explained why. So b is equal to b here. That means you can write any arbitrary number z here and z here, as long as you have e log in between. Again, e and log are two inverse functions. So feel free to write any number as e raised to the power of log of the same number here. So whether that be b or b. Likewise, you can write the same number is equal to log of e raised to that number. So as long as you follow this formula, they'll always be correct. Now, so those are the rules, number 1 and number 2, that you should take away with, which is as long as you follow, you raise e to the log of something, that number stays the same. Likewise, you can rewrite number x by saying it's log of e raised to the power of the same value. Now, one of the consequences of this is the fact that log of a product is equal to log of two numbers. So that's rule number 3. And the way we prove it out ourselves is we say a, we can write it as e log a, that we apply this formula here. Likewise, b is e log b. So a can be substituted with e log a, b substituted with e log b. So what it means is here. Now, when you multiply two numbers together with the same base but with different power, in this case e raised to the log a, or that means e has a exponential with the power of equal to log a. Likewise here with log b, when you multiply the two together, as you have probably learned in algebra, you simply add these two numbers together, okay? And likewise, because log e of something is equal to that something, so we can get rid of log e here, and it becomes log a plus log b. That means log a times b equal to log a plus log b. So we rewrite that in formula number 3, which should be another key takeaway. Similarly, when you have log of a over b, it becomes log A minus log B. In this case, treat treat 1 of B as B minus 1. You will come up with the same formula. Again, if A times n raised to the n, that means A multiplies by itself n times, meaning you repeat these terms n times, meaning you have n times of log A. So from number 3, we can derive log an equal to n log A. Number 4, as I mentioned, up here we use a base called E. All the rules that we have explained so far also applies when we have a base of n. So you can write log n to distinguish it from a regular natural or Neperian log without the letter here. Log n of n raised to the power of x is x. This is pretty much the same as this formula here. And then n, the base, raised to the power of log of n of something equal to that same value. And that just like key takeaway number 1 here. Okay? So let's go back to our problem. They want to find something which is wrong. Now we know that log A of B over C is log A B of B minus log A of C. So this is correct. Log A of B times C is equal to log A of B plus log A to C. We've seen it, so that's correct. This part, if you write B here, is A log A of B, you will find the right hand side becomes log A of B. This one becomes A log A of B. And because of that formula that we talk about here, which is this one, when you have something raised to the power of something, you multiply that power, you bring it outside of the log and multiply by the log A. So this one then become, you bring it up here, it become log A of B times log, I lost myself. Let me erase and rewrite it so you can see that clearly. So log C of B, we write B as A log A of B, and then we bring this thing outside to here, so then we got log A of B times log C of A, which is this one. So this is also correct. That means the 4 choices, this choice is wrong.